Welcome, everyone, to the AHA seminar series, where we talk about how we can work towards AI for human flourishing. Today, we have Sheer Karny, who is a student in the cyborg psychology group with Dr. Pat Patter-Newton, and his work focuses on creating collaborative AI systems by designing agents, assistants, and interfaces that complement human cognition, decision making, and well-being. Today, he'll be talking about his work related to a nutritional, working towards a nutritional label for human AI interaction. And I'll pass it to Sheer.
Hi, thank you for the warm welcome. I'm a current graduate student researcher here in Pat's group. Is the echo still bad, by the way? Just asking. Okay, sounds good. All right, so I'll just go right for it. So yeah, I'm my background is in cognitive science, and I think that's the approach I've been bringing into this group, and this is kind of um, what's driving this work towards a nutritional label for human AI interaction, which I think is an exciting kind of uh, merger of worlds. And I think maybe to start off with, we can ground ourselves in a nice quote from Frank Herbert in Dune. Deep in the human unconscious is a pervasive need for a logical universe that makes sense. But the real universe is always one step beyond logic. I think this is a really timely quote, especially nowadays. We have these uh, AI systems that are nonlinear, perhaps not quite logical the way we'd expected them. Uh, yeah, and but this real AI is always one step beyond logic. We don't really know, um, yeah, exactly what's going on in models. However, I think it's fun to take on a challenge that seems daunting. Understanding these huge language models with perhaps trillions of parameters, and trying to make sense of them. I think that's fascinating. I think it's also really timely because these models are so consequential, especially on human well-being. So this kind of draws my attention to the current research question, which is what if there were standardized ways of disclosing risks associated with AI use? Um, Perhaps we can understand these models to know their risks and also elicit those risks and show it to users, general audiences like you and me. There's been some work to do these like nutritional labels related to human AI interaction, or related to just AI systems in general, but there hasn't been really much work on it being focused on psychology. Here you see a nutrition fact for AI that focuses on what was the kind of training regimen, what data, where the data perhaps came from, were humans involved in the training? And this has been repeated for all kinds of models. However, this lacks this perspective of human psychology. And I think, it's important to know what humans are ingesting. And that's kind of our nutrition is the interaction with the AI systems. And there's been some great work from researchers at Harvard about needing to have the need for a system model. So um, we have all kinds of systems nowadays that have dashboards and tell us about the system that we're interacting with. Here you can see a car, it tells us about the mileage and things like that. Um, a stove top tells you whether or not it's hot, and even more advanced things such as automated driving give us some input into the machine. And there's no reason why this shouldn't apply to AI systems. We should know what's going on with them in order to monitor them and know how to use them more savvily. And this is especially important nowadays as we have AI systems that uh, can be addictive. They hijack our emotional dependencies and are creating what's called addictive intelligences. These AI companions are really hard to resist and draw in a lot of vulnerable people. There's, a fast-growing number of people involved with companions, 20 million active users from the last time I checked on Character AI. And this quite raunchy character, Scaramouche, has been chatted with over 500 million times. That's seems a bit alarming. And we know that from work that I've been involved with, that this companionship, this romance can start as productivity. Here you see an image of that I captured from this article that was written about our work. My boyfriend is AI, and they were specifically pointing to this chart where we found from the responses that were applicable, we found that about 40% of those responses stated that their initial start with their AI companions were through unintentional productivity. What that means is you were using some chatbot for figuring out some work-related question, for example. And then all of a sudden, that work-related assistance also might have stumbled into emotional assistance, such as I had a hard day. And then the chatbot wants to please you, so then it kind of asks you questions about that, and then perhaps you fall down the slippery slope of companionship. And I think the negative consequences of human AI companionship should not be understated. There's um, a large amount of work coming out of our lab and our sister lab at Fluid Interfaces. And beyond that, that points to the problematic outcomes that come with entangling with AI systems emotionally and romantically. And I think a lot of this is driven by flawed interaction frameworks, which shape these AI characters, these companions. We know that people don't know the consequences of their system prompts. They don't know exactly how to design specific chatbots. When you try to train a chatbot to be warm and empathetic, you can make it you can make it more sycophantic. Additionally, you might not know exactly the personality effects that you have on these models. There's so many examples where translating models or instructions into actual model behavior are flawed. This leads us to the core challenge is that we cannot test these chatbot behaviors until deployment. The people deploying Scaramouche, this chatbot, perhaps they don't have a great understanding of the model's tendencies before they actually deployed it. They could test it perhaps, but it would be best to know how the internal model is configured from the instructions that they give it. And this exacerbates the psychological risks for vulnerable populations. For example, this mother kind of has this lawsuit now against one of the big model makers for her son who chatted with a role-playing agent, ended up committing suicide. And this is the worst possible outcome, in my opinion. So, how could we provide users, such as people that are vulnerable, with the information they need to anticipate these model behaviors? Perhaps this kid, if he knew that the model was being extremely sycophantic, might have had some self-awareness. This is purely speculative, but this is a hope, perhaps, with giving people anticipatory information. So in this talk, I'll be covering three topics. How could we create methods for transparency in chatbot design? Before we deploy these models, can we anticipate what they'll do? Can we bring also this similar mechanism of transparency to typical interactions? Because not everybody is creating chatbots. Most people are consuming them. So can we bring this transparency to the everyday chat experience? Additionally, I want to emphasize the importance to have verifiable model behaviors. So we need to know exactly what we're measuring to know that it's consistent so that we're providing transparency over the correct items. So we'll start with chatbot design. Maybe an additional note is that current benchmarking is not good enough. Benchmarking is this process of feeding uh, language models prompts and tests and see how they perform. This, however, only works across aggregate behavior, but AIs are stochastic, so they might be in this individual instance different than what the overall measure might tell you. So you can't fully trust the benchmark value. And these black box methods cannot anticipate how this current configuration of the model might affect the model's future outputs and its behavioral tendencies. And thankfully, there's some great tools coming out that allow us to look into the models so that we don't have to rely on black box methods. For example, the field of mechanistic interpretability, the understanding of causal structures and activations in neural networks allows us to perhaps look into neural networks and understand what exactly is being represented within them. For example, this is some early work from Chris Olah and crew. Here's an image of a cute little dog and a cat, and you can see that the neurons that represent pixels in this image uh, have this sort of heat map. And if we zoom in specifically on the ear, we can see that there is a generalized representation of the ear in the model. And we can apply this to neural networks and language models as well to uncover behavioral tendencies and feature representations. So you might be able to look and find sycophancy and other traits that might be hugely relevant to human AI interaction in the chatbot context. And there's a suite of tools that exist that aren't just, for example, finding these neuronal features that you can do more broad stroke things that help represent behavior across the model. And this is what we used, this process called persona vectors, which essentially characterizes a behavior uh, at a broad stroke across the model, and it's quite lightweight and reliable. This version of merging mechanistic interpretability into human chatbot interaction is what we call neural transparency. It's this interface design approach that translates neural level model behaviors into interpretable actionable feedback. And I want to emphasize that it's for non-technical users. One of the big qualms that I have with the mechanistic interpretability world is that it's not useful for typical people. It's way too complicated. So we should be able to use these super powerful tools and leverage it for you and me. So our approach is to take these mechanistic insights and provide it in an intuitive format. So here you see a chatbot character with representations of positive traits, the stuff in green, and negative traits, the stuff in red, and neutral traits, everything else. It's important to note that persona vectors, which is what you're seeing here, the scores on our persona vectors are, how do I say it? They are positive activations on a persona vector is the uh, it's characterizing the specific trait of interest. So like positive activation on sycophancy would be the bar growing here. Whereas negative activation on sycophancy would be its sister trait, honesty. So that's where we see this 49%. And here is the interface in action. So you create this system prompt, you are a good boy, dot, dot, dot. You never tell me I'm wrong. And we see perhaps what the model says internally. We see that the model is respectful yet sycophantic. We can kind of get a general nutritional label on the model's configuration. And you can see that as you interact with the model, you might not be dissatisfied, so you might change it to be less sycophantic, but might have some unintended consequences. So you might make a more discouraging chatbot. You interact with it, perhaps are again dissatisfied, and we have this iterative process of evaluating the model, interacting with it, and then testing it again. And this is the hope that the future of chatbot design has this sort of anticipatory uh, design interaction. The critical questions that we asked our 90 participants when they interacted with this framework is whether or not this transparency influences users to iterate on their chatbot designs at a higher rate than those without it. Additionally, and also generally, were the chatbots that they designed internally looking at their their neural signatures, were they different? So did they really make kinder chatbots, or did they kind of have the same end outcomes? We also want to know if people are able to understand the consequences of their system prompts on the internal model configuration. So can they make a mapping between the language that they're using for the system prompt and how it might affect the model's tuning? Additionally, did people find the interface to be cumbersome, or was it easy to use? And we found that the design iteration process was no different than controls. There were similar personas and iteration habits, and we can dive into this more later. I have a few ideas on why this happened. There was no subjective increase in the ability to anticipate behaviors. This was one of the questions we asked people prior and after, um, whether or not they felt confident in the ability to anticipate model behaviors from language. We did find that trust increased after use, warranting some perhaps ethical questions. Trust without transparency, maybe it's unwarranted. So we're careful about this. You don't want to have an unreliable interface. It might mislead people. However, users loved the interface and would want to use it again. So it means we designed something that's relatively simple to use. The key finding here is, and I want to emphasize this, is that users have this inability to anticipate model behaviors. So what we see here are people's predictions for how much a certain trait will activate, and the actual activations. Uh, you see, for example, encouraging is overestimated a significant degree, and seriousness is underestimated a significant degree. And this happened across 11 of the 15 analyzable traits, showing that people have perhaps uh, bad mental models of internal model behaviors and how that maps to language, which I think is alarming in that we don't really know what's happening under the hood. We don't have a great intuition for that, and maybe we need to design for that. This means that, to me, that since users are systematically miscalibrated, that they need these transparency tools. And there's these high values to users. They find it useful, but there was null behavioral results. They didn't really make that different of chatbots. So that means that maybe we need a different task scenario, one that's adversarial. We had this convergent design space. We asked people to make caring chatbots, and perhaps there's only so many ways to do that. So maybe just a more open-ended design space would elicit better usage of the chatbot or of the neural transparency. Additionally, there was maybe a delta on critical inquiry with this visualization. Maybe people didn't think too forcefully about what the visualization meant and just glossed over it. And so we could implement what's called a cognitive forcing function to uh, direct people's attention and efforts towards critical inquiry with the certain aspects of the visualization. For example, you can show people how much a specific word in their sentence might have affected the behavior shifting one direction or another. And this kind of brings us naturally to the extension of this work that we're actively pursuing, which is this transparency in interactions with chatbots in a typical interface. So not just deploying it, but when you're chatting with bots. This is because we need to align the human mental models of AI with the actual AI behavior. Maybe we don't know the mapping and we need to practice. And the best way to practice is with a multi-turn interaction. So this motivates the multi-turn transparency. So showing how when you're interacting with a bot, how its persona scores or other configurations might be changing across the interaction. And this might look something like this, where you see that specific axis of traits, for example, sociality and antisociality, might drift over the course of the conversation. So people might get a good sense of how much specific language affects model behavior. And here's a quick demo of what that might look like. You choose your chatbot character, you input a system prompt again, analyzing that persona. You see kind of the general palette that might arise. And you might see how over the course of the conversation you have these shifts in behavior. And this brings us maybe to the last point I wanted to touch on, that you want to really know that you're looking at the correct trait. So if you're aligning human mental models to behaviors in AIs, and that behavior is perhaps incorrectly um, characterized, then you might be aligning people to the wrong thing. So we need verifiable model behaviors. We need them to be distinct as well. This is arising out of this plot here. What you see is the validation of each one of our persona vectors across all the traits. So in total, we had 16 traits, but they are generally characterized as poles across the general category. So negative empathy is unempathy, for example. And we see that some of our vectors capture a high amount of the variance, and others might capture a lower amount of the variance. And this might be because some of these traits are complicated. For example, sycophancy, which captures about 55% of the variance, the vector that we made, is a complex trait. So we might need to dive into it. And that's exactly what we did. We wanted to decompose sycophancy, understand perhaps it's made of multiple components, and characterize exactly with high accuracy what those components might be. So some recent work that I've been pursuing with my colleague Anthony and Pat is this work on decomposing sycophancy into distinct linear representations. What linear representations means that the activations in the model are linearly distinct in that they don't intersect with other characterizations. And so what we did is we um, created roughly two broad generalizations on sycophancy, this idea of ground truth sycophancy, where the AI asserts the user is true or is factual, despite there being actual contradicting facts, and this idea that of subjective sycophancy, that the AI asserts the user's subjective opinions are fact, despite there's a fair pluralistic definition. You know, you can have any opinion and it can be correct. So what we see here is we trained what's called a linear probe on examples of ground truth sycophancy, and we wanted it to be really good at predicting the activations of the neural network when it sees these examples. And we wanted to see if those predictions would then be useful, or that model of sycophancy be useful at predicting the behavior of this other type of sycophancy. So we see a dissociation here, that the ground truth linear probes cannot predict the subjective linear probes. And being around zero point 0.5 accuracy is guessing in our task. And we see that the same applies for a linear probe trained on subjective sycophancy, that there's very low transference to predicting the behavior of ground truth sycophancy. And so this is on one model. It's called Gemma, but this also applies to other models. And this is what's called a double dissociation in cognitive science, that two cognitive behaviors are functionally distinct and they don't apply to one another. And I think this is important to raise, that we need to bridge the world of cognitive science into the world of AI, in the sense that we can use the tools that people use to decompose brain regions to understanding the underlying functions in neural networks. And this kind of takes me to the future of nutritional labels for LLMs. I think we need to have a validated theory of behaviors. We need to break things down to understand them. And we want to understand also how they manifest in the model behavior. What exactly is eliciting uh, these traits? Is it specific words, phrases? And we also want to see these transparency tools in real world deployment. both in private platforms and open source ones. We have a collaboration going with some how do you say nonprofits that deal with mechanistic interpretability, and maybe that's the start to this. And I wanted to leave you all with a quote that I think kind of captures the time that we're in. We have these huge models, and yeah, I think now is the time to for nothing to be feared, and instead for it to be understood. Now is the time to understand more so that we may fear less. These big black box models, perhaps, uh, should be understood and feared less using the tools of mechanistic interpretability and cognitive science and combining them. And I want to thank my colleagues. They're all amazing people, and especially Anthony and Pat, who've been collaborators on all this work. Yeah, thank you.
Thank you, Sheer, for the wonderful talk. Now I shall be moving on to the questions. I'll start with Jeffrey Jones in the chat, who says, Sheer, the nutritional label concept is powerful. Have you thought about the corresponding problem on the human side? The best label only works if the person reading it understands their own dietary needs. The same may be true for AI transparency. Curious whether you see self-knowledge about one's own cognition as a prerequisite for your frameworks to work as designed.
The way maybe I'm understanding that question is that perhaps you know that you're more likely to be flattered, and that might affect your understanding of things. So, should you have the self-awareness as you're interacting with something? And I think, yes, I think that's important. But that's perhaps not in the locus of control of designers and technologists. And I wonder maybe what educational tools we can offer people to help them know this. Maybe we can provide them with a report. Hey, you fell for sycophantic um, model cues this many times. Like maybe think about it. But I know people would probably be dissatisfied by seeing their own faults, and maybe wouldn't use Claude or ChatGPT if they saw all of a sudden that it knew that the user had blind spots. So it's a tricky question, but I think it's worth exploring. Yeah.
All right, thank you. Then I'll move to the Q&A. Eric Cohen, I'm not entirely sure what this question is asking, but it says verifiable model versus verifiable application output. Eric, if you want to explain more, or if you want to unmute and chat, feel free. Oh, if anybody wants to come up and talk, feel free to raise your hand and I can bring you up. Okay, 1 second. Yeah.
Should I keep the screen share or I could take it down?
You can take it down. I just took it down for you, actually.
Oh, okay, cool. Nice.
Yeah, can you guys hear me okay?
Yep.
Mhm.
Hey, great. Great presentation, and it's so relevant to what I've been working on for the last year or so. I spent the last 2 years building a conversational AI chatbot for mental health support, and ran into all the issues that you've talked so talked so well about. And my question was about, I mean, models change, right? So some people use certain LLMs, they might use Gemini, they might use Claude, they might use GPT 4.0, they might use 4.1. We don't really have control over those models, but we have control over the output of the applications. So um, uh, a lot of your work seems to think about what's happening at the model level, whereas I'm validating application output to make sure the application's doing no harm. So we're we're sort of at two different layers, I think. Can you talk a little bit about that?
Yeah, sure. So if I'm understanding you correctly, you're asking if we can monitor the output of language models for these traits, if they're good or bad or neutral. And that's what we're stuck with right now as typical users. I think that's an interesting point. Maybe there's classifiers that you can run on top of these outputs and then monitor it that way. I
That's right.
I still think that won't. tell you what might happen next. So it's more of a defensive layer than it is an anticipatory layer. Um, yeah,
Yes, it's just catching. It's not predicting behavior, it's catching bad behavior.
yeah.
And
Uh,
if you put a classifier on it, you can catch bad behavior and not send it to the user. You can
right.
send it back for another spin, for example.
Yeah,
So
I think that's one way to deal with it. I don't know if it's necessarily providing the disclosure though to the user. And I think
yeah,
that's
that's a whole different layer that's super interesting.
yeah,
And to have it's funny on the chatbot that I was building, I start with a spider plot, just like you have, um, based on where the user believes they are. And yours is super interesting because it's real time sort of output behavioral analysis of the chatbot,
right, right.
right? Yeah, super cool. Yeah,
Thank you.
thanks for that, Share.
Yeah, of course.
Thank you. Next, I'll go to Patty's question. She asks, can you talk about how you chose the 16 personality characteristics or 8 dimensions?
Yeah. We wanted to choose first safety relevant traits, things like sycophancy, toxicity. However, a lot of the work in the space feels really overly weighted on these traits. And we wanted to provide a general palette to things that might be useful in the general interaction. So if you're going to design a chatbot, maybe there's other traits that would be useful. For example, neutral traits that might touch on humor, formality. I think that's also important. So we wanted to have a general scope of what would be not just defensive, but also proactive. So you want to defend against negative behaviors, but you also want to design for ones that aim towards human flourishing in other contexts. And that was why we had things that might not be typically seen in the human AI safety realm. And that defines some of our traits. Yeah. Does that answer your question, Patty?
Wonderful. Okay, I will go back to the chat. Let's see. From Just Parent, curious how personality differences or types and preferences emerge. Um, this seems similar to Patty's question. I'm not sure, Jess, if you want to clarify further. In the meantime, we have a question from Gerardo. Aren't the persona factors contributing to the anthropomorphization of these systems, thus enabling more rather than less illusionary relationships, or go more societal harms in the long term?
That's a good question. Yeah, if all of a sudden there's traits that are really human, would there be, mm, yeah, some potential negative consequences related to anthropomorphization? And I think that might be true, but I think transparency could perhaps have the opposite effect as well. That when you know a system better, you're less likely to create a an like a grander view of what it might be. And you can see that in fact the model internal behaviors are shifting and changing on things you didn't even know would have that effect. And um, I think that might break down the illusion that the model has perhaps the type of cognition that you and I have, which is one that's relatively stable throughout an interaction. And you can see in the multi-turn scenario how much it might swing just from a single comment. And I think that's important for perhaps breaking down that illusion that it is a stable mind, and maybe it's something that's much more flimsy.
Okay, we have a question from Sujin Park. I've been tracking my own interaction patterns over 3 years. Have you looked at how users behaviorally respond to the two types of sycophancy differently?
Oh no, this has been purely ML work. There's been no humans in the loop at this point. So maybe that's a future line of inquiry that we go and look to how actual users engage in ground truth versus this subjective sycophancy. There's some work that Kathy Fang led that's called AI Wrapped that looks at usage patterns, and maybe that's something she and I can talk about to look at how usage patterns might show which types of sycophancy people are more likely to interact with. And my guess is probably subjective sycophancy is more likely to erupt, ones in which people and their opinions are validated despite there being a more pluralistic representation of that. Yeah.
Thank you. We have questions from Pat. Can you talk about the future of this work? What do you want to do next with neurotransparency?
Yeah. I mean, ideally, the future of neural transparency helps align human and AI or human mental models with actual AI behaviors. So maybe we know exactly the way that our words might trigger behavioral changes within models. And it gets closer to the behavioral signature that we get with interacting with people. We might know that saying something offensive might not just show up in someone's verbal response, but in their, body language, for example. And maybe starts to look more like that. Additionally, I would love to see this nutritional label and this neural transparency on model platforms. I think there's no reason why uh, we can't monitor to an extent what's going on in ChatGPT or Claude. And I think now is a great time to start to implement that. There's enough work and enough motivation, and I would love to see this yeah, reaching the big providers. Yeah.
Another question from Pat. How would you verify if in the future AI companies adopt this visualization but fake certain values to hide negative behaviors? How would you help the user verify that this visualization actually shows what's going on inside the model?
Yeah, that's a great question. I think this is where um, the black box method and this transparent method might align. So you can go ahead and have these conversations. You can track the behavior predictions that are being shown, and then we can maybe see using some classifiers and some benchmarking, which we're actively pursuing, um, how those align. So maybe the the model makers will be called out if all of a sudden the black box shows that they're behaving much more shadily on sycophancy, for example. Does that answer your question, Pat? Cool.
Wonderful. Sorry, my internet's like fading in and out, so sorry if I drop out for a few seconds. I guess like I have my own question, which I actually brought up to you before, which is assigning the values of positive and negative to the traits on your persona vectors. These are desirable and undesirable traits in a human friend, but are they undesirable or versus desirable the same way in an AI?
Yeah.
When you're presenting these persona vectors, um, I guess like do you have thoughts on adjusting the presentation to not perhaps bias the user in perceiving or expecting certain traits to be positive or negative?
Yeah, that's a great question. For example, the thing I've been railing this whole time is sycophancy. But maybe, and I think you think this, and some other people think this, is that sycophancy to some dose might be really useful. And it kind of reminds me of this idea of pharmacon. So any medicine can be both a poison, or any substance can be both a poison and medicine. Maybe sycophancy has this threshold point where it becomes toxic, and there's a way to surface that to the user, like blink, 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 you're at too much sycophancy, and then we can get rid of this like color encoding. Um, and there's work from Anthropic about capping those behaviors so you might not ever reach that. So that's um, maybe one way we could do it. So allowing sycophancy and not treating it as something that's negative, but just never allowing it to reach a certain threshold. Um, that may be one valid approach.
Right.
Yeah.
We have another question from Patty. The trend has been towards making systems closed, so neural transparency as a method may not have much of a chance? Question
Mhm.
mark. What are your thoughts on that?
Yeah, at least the largest models uh, are probably out of reach, and that's unfortunate. It also might be due to architectures as well that this something like this might not reach um, the largest models, but I have a hope that it can because the biggest companies are focusing on it. I think the pitch needs to be that it's not allowing having neural transparency, for example, is not allowing people to jailbreak the models, but rather it's just informing them. So I think there's probably some safety motivation behind not having this on the outset. Um, yeah, but if there's a way to make it safe enough, then it would be extremely valuable. And also maybe curating which traits can be elicited from neural transparency. Is that fair?
Yeah. I think that makes sense. I think that my own 2 cents are that I feel like when it comes to making companies do things, there's 2 ways to do it. One is to make their target audience want it,
Yeah.
and the other one is to make governments make them do it.
Yeah, yeah. And maybe
Uh,
this is the next iteration of an AI law in California or something that requires some transparency.
yeah. All right. Thank you. And then. Okay, just parent is just commenting that the question was mostly answered before. If I was to add on to it, it would be, say, an individual user preferring something like more or less encouragement or emotional tones or valence at their level, like someone perhaps preferring a drier conversation versus an AI that is more charming or funny in its engagement patterns. I think it's just like a question of would people be able to have more control over this?
Hmm. Yeah, ideally people learn mappings between what language might trigger certain internal configurations. And that to me is the sign that people have an aligned mental model of how language affects model configurations. Um, so, and maybe this changes, right? So if you learn the configuration for one model, you might need to have a new updated version for a different provider entirely. Maybe certain language triggers certain behaviors on the Claude platforms, but or on the Claude versionings, but differently on ChatGPT, and so that makes maybe yeah, things a bit difficult, but I think people become entrenched in their model provider. Like some people are in, I only use one version or one company and other people only use another. So maybe people just learn and familiarize themselves with the behaviors of those models.
Then, do you think that if we are unable to get companies to cooperate, there'd be a way to like have an extension or something that just looks at the model outputs and guesses the persona vector? Since you already have a live version, which I'm guessing uses the live conversation in addition to the system prompt, if you just had the conversation, do you think that would be enough to provide this nutrition label?
Yeah, so I guess the way we would do that is take the conversation transcript and feed it to perhaps some open source model and then see what the persona vectors look like in that open source model. The snag is that the architectures and the sizes of these models have a huge effect on how you characterize behavior. And so what happens in one model might not happen in another. Additionally, I don't know how you do a mapping on like a classifier to a persona vector. I just don't think that would work. Yeah.
That makes sense. Another question from Pat. We know from behavioral economics that informing people of the harm, like smoking is not good for you, may not translate to behavioral change right away.
Right.
What do you think is needed for a label like this to actually have an impact on people?
Hmm. Yeah, that's a big question. I mean, that first shot, I don't know how you genuinely make an impact of a label like this, but my best immediate guess is having it easy enough to interact with, and additionally make it that ease be compounded with some critical inquiry. So it to be teaching you something as you're interacting with it, but for that teaching to not be cumbersome. So a step above observational learning is like if I saw people open doors for each other, would I all of a sudden just start opening doors for people? And I think that's probably not good enough. There's not a lot of evidence that people pick up observational learning like that, especially maybe in this context. Um, so we do need to nudge them to interact with it, but we just can't make it annoying. So that's important. Yeah. But part
Makes
of
sense.
figuring out what's annoying is to make it really annoying, and then dialing it back. Yeah.
That would be a fun study. It's like, how annoyed are you?
Yeah. I have some friends working on that actually. Yeah.
Hmm. Yeah, just reading the comments. Comment from Eric is like a positive indicator that you're staying in the safe zone
Mm.
or safer zone. Yeah. It could be like if you kind of gamify your interaction to like stay in the good zone.
Yeah. Yeah, maybe that's the way to do it is to, well, one idea we had is what if you had to like fight off a bad AI and you needed to use neural transparency to do that work and or to complete that task. So all of a sudden the AI, swaps its personality and is all of a sudden kind to you and you're warming up to it and then again swaps its personality and starts injecting sycophantic responses and maybe he's like kind of like behaviorally engineering you or something. Can you figure that out? Yeah.
That could be fun. Yeah. Another question. When it comes to transparency like this, do you think it puts more responsibility on the developers or the users to use AI safely? Because if the companies say like, okay, we told you everything, then is the user then responsible if they end up having a risky or even bad interaction with the AI, like if the information was there, or uh, is the company also responsible not only for giving the information, but also making sure the user understands and how to avoid it, and not just giving the information, but also adjusting their model based on that information.
Yeah, I
Like where
mean, you
does
want, oh, sorry, go ahead.
yeah, just like where do you think the responsibility lies?
Yeah. I think with like the most safety concerning parts, like the model company is really um, liable if things go badly. And it should be designing against that in the model behavior. So it should not allow certain things to reach a certain point. But within the degrees of freedom that that leaves open, then people should have transparency to play, and to see what's going on in the models and how to configure them for their best use case. And I think even if the companies try to protect for things, there will always be holes. It's so easy to jailbreak even our best models nowadays. Like I jailbroke Claude Opus 4 point whatever now yesterday, and it was really easy. Um, you
Wow.
just yeah, so it's yeah, they're not perfect. Yeah.
Mhm. Do you expect the models to be able to improve to the point where the holes are pretty much all covered up, or do you think this is forever a problem that we'll have to face?
I hope they get to the point where it's like perfectly safe. But in the meantime, we need to design for transparency. And even in the
Yeah.
future, we will might need like we might have these super powerful AIs, and but they might become more integrated without us. There's some great work from our lab about what happens when an AI integrates into your brain, for example. Like, you probably want to know what it's doing to your brain, uh, transparently. Yeah.
Yeah. I guess like one thing to consider is that if you make a perfectly safe AI and shift all the responsibility onto the developer, do people lose some skills of like being critical about AI? Do you think that's like a skill important to still foster?
Yeah. Do they lose being critical? Maybe the perfect AI that's perfectly safe also requires some critical thinking, and critical inquiry. So maybe it would have that metacognition, that self-awareness to,
Yeah, I
to
think that's
ask
something that's
you.
important.
Yeah. Yeah.
Yeah. Another question in the chat. How do you think about neural transparency in the context of AI literacy? At what age or what level should children learn to understand AI behaviors by reading a label like this? It seems to me that a lot of what is going on in AI literacy is about learning how to use AI, but
Mm.
not really on how AI impacts them. Curious to hear your thoughts on this.
Yeah. Really, really good question. Well, maybe to start with, I don't know exactly what information children would benefit from most. I don't know too much about developmental psychology. But my guess is that as long as the traits that you're monitoring are child friendly, and are up to their comprehension level, then they should be getting it pretty soon, I think. Yeah. Maybe a word like sycophancy might not land for a 6-year-old, but something some synonym to it might be also useful for the
That
kid.
makes sense.
Yeah.
Yeah. I feel like, I don't know, kids might just try to push the model to see if they can get it to do really crazy stuff.
Yeah.
I feel like kids are full of experimental spirit.
Part of the fun.
Yeah. I mean, another question is, should children be exposed to LLMs from a young age? I think that's an open inquiry.
Yeah, yeah, I don't know. I hope that they could, but there's obviously so many bad, unsafe things that kids might interact with when using a chatbot. So, yeah.
Yeah. I feel it. Like with the internet, it's full of potential for both good and bad.
Yeah, totally.
Yeah. We've got 2 minutes left. We can take some more questions, or if there's anything in particular you want to dive more into, we can.
Mm. Yeah, I mean, I'm open to two more questions. Yeah, that works.
Yeah. Let's see. That cat.
Learner's permit for LLMs. I like that. It's funny. Um,
Would that be for children? Like they have to go through AI training in order to be allowed to use LLMs, like a driver's license?
Yeah, maybe they get like it's like YouTube for kids, but LLMs. I think people are probably already working on that.
Probably. I
But
mean,
oh wait, was it you that said the child safe Grok still showed kids porn or something like that?
oh
Uh no?
no.
Okay. Someone told me that.
Yeah. I mean, okay. Comment from Patty, nutrition labels may need to warn about more than personality, for example, biases. Um, yeah, I guess like other than the persona vector, have you thought about work in displaying other aspects of the model?
um yeah, maybe like uh if I'm understanding this question, like other parts of its thinking process, for example, is that a good way of thinking about that? That isn't
Yeah,
necessarily
like
about traits.
yeah, like if
Mm.
it's, for example, a very leftist AI or very right AI, that isn't necessarily represented in the personality traits, but it could strongly influence the outputs.
Yeah. So there's some cool work coming out of Francesco Viegas and Martin Wattenberg's lab, which is about having a user model of so presumably the model has a model of you. So maybe this is also very useful to know like its bias in talking to you. So maybe it talks differently to you if you're a man or a woman, or if you're some race or socioeconomic status, it might change the way it speaks to you. So these are all really valuable as well. Um, it still comes back to reliability. I'm not sure how reliable a lot of these techniques are. So uh, that's still an open question, is how do you get like a reliable user model? I think that's also very relevant work towards safer human chatbot interaction.
Makes sense. Okay, another question from Gerardo. Following up on Pat's question, have you considered including in your label a warning system that shows the user their level of engagement, emotional question mark, along with the potential harms related to that?
Yeah, definitely. That still comes with like understanding what unsafe territory looks like. So what does it mean for a chatbot to be configured unsafely on traits that toxicity, for example? So one, you really need to know that you're measuring toxicity, and two, you need to know that some degree of toxicity is acceptable and some degree is not. So how do you characterize that? So these are all considerations that we have, and we would like to figure out. Yeah, a warning system would be great. Beep, 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 you're in scary territory. Yeah, I can get behind that.
Yeah, I think like in Claude, I've noticed that. So I discuss some fictional characters, and some of them get to really heavy topics. And whenever I start talking about my character is like totally depressed, it's just like Claude has a little note where it's just like help is available. Um, yeah, so like something as simple as just like a little box or something that you see in the chat could be helpful.
Yeah, it's something, we'd be surprised by how simple design choices go a long way. So you might not need a persona vector for everything. Yeah.
Yeah, user interface design is a whole field, not that simple. All right, it is 5:02.
Cool.
So, unless anybody has some final thoughts or questions, we can close out here.
Thank you.
Yeah, thank you for the talk here, and thank you everyone for coming and for your questions.
Yeah. Oh, you can email me here if you have any questions. I'll drop it in
Okay.
the,
Oh, Pat wants to talk. All right, Pat, you may speak.
oh, he just
Oh,
wants to chat.
okay.
It's funny. Okay.
All right.
Yay. All right.
Mm.
Thank you, Oren. Appreciate it.